Welcome to Gario. So in this episode of the LeetCode series, we are going to solve a question called single number. So as usual, let's get started by first reading the question and then try to find an algorithm by checking out the examples given. And later with that algorithm, let's go to LeetCode and solve the question. So let's get started. So here we have a question single number. Given a non-empty array of integers nums, every element appears twice except for one. Find that single one. So what they have given to us is, for example, let's say we have an array called 1 1 2 2 3. So in this, the element 1 appears twice, element 2 appears twice, but the element 3 is the only number that appears only one time. So that's the single number that's given here. So if we are given an array like 1 1 2 2 3, we would have to write an algorithm which finds out that number 3, which is not repeating twice, its count is just 1. So that is the question that is being given here, and the constraint that they are given here is that we have to implement a solution with linear time complexity, which means it should be of the time complexity of big O of n, and it should use only constant extra space, which means we can't use an external array or a hash map which takes extra space in order to store these values. Okay. So these are the two constraints that are placed here. So how do we get to solve this question? In order to find that, let's get to an example. So here we have a very simple example, 2 1 2. As you can obviously see that 2 appears twice in this array, but the element 1 appears just once, and hence that is the single number of this question. So how do we write an algorithm or develop an algorithm to find this? So what would be the usual approach without any of those constraints? Our usual approach is going to be like, we find the count or frequency of each and every element. So what is the count of 2 in this array, which is 2? What is the count of 1 in this array, which is 1? Similarly, if we had n numbers, we'd find the count of each of these numbers. And then with that count in our hand, we'll check whether which number in that array or hash map that we have stored this information in has a frequency of 1, and that would be our answer, because that is the single number that doesn't appear twice. Okay, every other number would appear twice except that number. So that would be the usual approach that we solve this in. But since we can't use extra space to store that frequency or count information inside an array or a hash map, we would have to think of another solution, and that is where our bitwise operators come into action. So here we have the truth table of an XOR operator. Okay, so what is an XOR operator? In simple terms, it just gives us the output of 0 or false if both the inputs are same. So here, as you can see, 0 and 0 are same inputs, hence the output is 0, and 1 and 1 are the same inputs, and hence the output is 0. But in case if the outputs are different, 0 1 and 1 0, the output would be true or 1. So in simple terms, if the inputs are same, the output is 0. If the inputs are different, the output is 1. As simple as that. So we are going to use this exact concept in order to solve this question. Okay. So how do you solve it? So let's get to an example here. So 2 and 2. As I said earlier, this is a bitwise operator. Hence, we are going to convert these decimal numbers into binary bits. So as we know, 0010 is the binary representation of the number 2. So let us take that bit and get started with applying the XOR operator. So as we saw earlier, here we have 0 and 0 as the first bit. So if the bits are same, the output would be 0, and that is what we get by applying these table in the question. So 00 gives us 0, and 1 1 is also same, and hence gives us the output as 0. And similarly for the other two inputs, as you can see, these both are same input gives us the output of 0. So that is the answer that you would get if we apply XOR the same number. So 2 XOR 2 gives us 0. Okay, so that's the first observation that we make. If we have two decimal numbers and we find an XOR to it, then we would get the output as 0. Okay, so that is the first observation. Now with this, let us move on to another example, 2 1. And as we saw, this is the first two numbers in the input that we saw earlier. 2, 1, 2 and 2, 1 is the first two bits. So let's take these two numbers and perform the XOR operators for this. So 0 and 1 are different and hence we will get the value of 1 here. 1 and 0 are different, so 1 again, 0, 0, 0, 0, both are same inputs and hence we will get 0 and 0 here. So with this as our temporary answer, let's get to the third number. As we saw, 2, 1, 2 is our input. We have just completed the first part. Let's get to the second part. So we'll take the value of 2 here, 0, 0, 1, 0 and the value or the previous answer that we have, 0, 0, 1, 1. Let's perform XOR operator to this. 0 and 1 gives us 1 because the elements are different. 1, 1 is same, 0, 0 is same and 0, 0 is same. Since all these values are same, all these bits are same, by the truth table we'll get the value of 0. So that is what we get here. So this is the answer that we get by doing XOR operator to all of these numbers. 2 XOR 1 XOR 2. And the final result that we get is 0, 0, 0, 1. Do you see something interesting here? The decimal representation of this is 1 and this 1 is actually our answer. As we saw, 2, 1, 2, 1 is the single number. So by performing an XOR operator to all the numbers in the given array, we finally end up with our answer. So how does this happen actually? As we saw in the earlier case, if we apply the XOR operator to the same number, 2 XOR 2, the elements get cancelled and we get the output as 0, right? And by similar logic, if we have a set of array of elements like this, here the element 2 appears twice, element 5 appears twice and element 3 appears twice. So when we perform an XOR operator, they get cancelled. So 2 and 2 get cancelled to 0, 5 and 5 get cancelled to 0, 3 and 3 get cancelled to 0. So the only element that is left is 1 is 1 and that is what we guessed as our output or the answer to this question. So this is how the question and the logic works. So let's get to the pseudocode part of it. So what do? We first initialize the integer XOR value as 0 and iterate to one of these array elements, take every element and then XOR it with the previous answer. So we have this whole array of elements, 2 XOR 1 XOR 2 and similarly it goes on until the end of the array. And that will be performed and finally all those elements which will cancel as we saw earlier and the answer that is present in the variable XOR at last after the iteration will be our answer. And as you can see here, we didn't use any extra space, it uses constant space and also we have just used a single for loop, which means that we are using linear time complexity. So that also gives us the solution which follows our constraint. So let's take this algorithm, move to LeetCode and solve this question. So here we are in LeetCode, we have to complete this function called single number. Here we have the integer array as input. Now let's start with the first element or the first statement in the pseudocode, which is declare a variable called xr and assign it to be 0. And the next step is to traverse this array of elements. So for that I'm going to use a for each loop. So int x colon nums. Okay. So the value of x are going to be for the input. So if the input is 2, 1 and 2, the value of x is first going to be 2 and then the next iteration is going to be 1 and then in the last iteration it is going to be 2. So with these as the values, what do? We perform the XOR operator to them with the previous value. So XOR is equal to the previous value of XOR and then we are XORing with the value that is stored in X. So initially the value of XOR is 0. So 0 XOR 2 will get stored here and then we'll have a residual value, the answer in the previous iteration, right? So that value XOR 1 and then that value XOR 2. Similarly it goes on until the end of the list. So at last, as we saw earlier, the elements get cancelled and then we can return the value that is present at last. And this would be the only element that appears once in this array. So let's run this code and verify whether we've got all of this correct. And loading. 2 hours later. Yeah. So as we can see here, the 3 sample test cases have been accepted. Let's submit the code and verify whether it works for all the other test cases that are given here. Yeah, congratulations, you have solved the question of single number with this. So if you want to try it out, the link to this question will be in the description. You can always check it out. And for future episodes, subscribe to Code. So see you next week with another episode of LeetCode. Bye bye.